The next question is, state Gauss's law in electrostatics. Use this law to derive an expression for the electric field due to an infinitely long straight wire of linear charge density lambda. We can see the answer now. Actually, question starting with state Gauss's law, right? So many question we answered that one. Total electric flux over a closed surface is equal to 1 by epsilon 0 times the net charge enclosed. Okay, that we have to write the statement first. After that, we have to start this derivation. There are 3 applications. This is the first application, electric field due to a charged wire. For that one, I just drew one line here having charge density lambda, and P is a point at a distance r from that wire. Okay. Now to complete the derivation, we are drawing one Gaussian surface in the form of a cylinder of radius r. You can see the cylinder is formed here, and the point P is on the cylinder. Okay, and I am marking the electric field direction which is away from the positive charge, so directed away from the cylinder, and the area vector also away from the cylinder. So here surface we are calling S1, or ds1 is the small area, and since they are parallel, angle between them is 0. Okay, and top and bottom surface also we want to consider. The top surface we are going to call S2, that is the small surface area ds2, and electric field still on the same direction away from the cylinder, so angle between them is 90 degree. Okay, now when we come to the bottom area, bottom also we want to draw the same way, where electric field will be directed away from the wire, that is away from the cylinder, and area vector will be acting downward direction, so that is we are going to call ds3, and the angle between them is 90 degree. Okay, then we will introduce a small sentence like what is this about. So one paragraph you want to write, that you can write your own way. Basically idea should be what I gave here, that idea should be there. So electric field due to infinitely long straight wire, then something right like consider an infinitely long straight line charge having linear charge density lambda. Okay, and to determine an electric field at a distance r, what we have to do is consider a cylindrical Gaussian surface of radius r and length L. Okay, coaxial with the charge. By symmetry we can say that electric field E has same magnitude, okay, at each point of the curved surface. Okay, like complete the sentence. After that we have to do the mathematical part. The mathematical part, basically there are 3 surface, right? Curved surface, top surface, bottom surface. So total flux will be equal to the sum of these 3 flux. So I wrote integral E dot ds is equal to integral E dot ds1 plus integral E dot ds2 plus integral E dot ds3. So integral E dot ds1, there the angle between them is 0. So cos 0 is equal to 1. So that exists. So the first part of that statement exists. Second part you see cos 90 coming, because of the top part angle is 90. Cos 90 is equal to 0. So second term of the equation does not exist. Similarly third term of the equation also does not exist. The reason for does not exist is cos 90 is equal to 0. Okay. So what to do now? We have to write one statement. What statement is? You remember linear charge density one statement was there. That we have to write. For that one just to mention or do like this one. Lambda representing the linear charge density, and L represents the length of the wire, Q represents the charge enclosed. Then you can write that expression, linear charge density one expression was there, that you can write lambda is equal to Q by L. If you do cross multiplication of L to the left side, you will get Q is equal to lambda L. Now what we do is we can write the Gauss's theorem. You know that Gauss's theorem is E dot ds 1 is equal to Q by epsilon 0. Now we have 2 flux equation, right? One flux equation is E into 2 pi RL, other flux equation is Q by epsilon 0. Equate those 2, because both LHS are same. So RHS equating now, E into 2 pi RL is equal to lambda L by epsilon 0. So the final expression for electric field is equal to lambda by 2 pi R L epsilon 0. Thank you.